Hey everybody, welcome to today's video. Our topic is going to be an introduction to data filtering in Pandas. So quickly, what is filtering? So filtering is essentially displaying a smaller subset of your data based on some criterion or criteria that you choose to specify. So looking at our sample data set for today, filtering is essentially taking this data set here, and this is a random sample of 10 rows, and deciding to show only what you want to show and nothing more. So you're taking this large data set and you're filtering it down to something smaller. This is a data set I got off of Kaggle. I did a little bit of data adaptation here, but other than that, it is still the original data set. Link to that will be in the description if you want to download and follow along. So let's look at the few ways to filter data frames in Pandas. So first is a simple filter on the indices or the rows. So that means you are taking all of the columns and you're cutting the data frames based off of rows that meet your criteria. And our syntax here is as follows. So the name of our data frame, which in this case is going to be df, open brackets, and then passing through a row filter. And we filter based on a series of booleans, or true or false. And the boolean series must be equal in length to that of the data frame that you want to filter. So let's take a look at our example here first. So we want to show all wins by Manchester United, and we have a column here for the winning team. So our series is going to look like this. So df winning team, this is currently just a series with this column here, and we want to create booleans out of that series. So we only want to show values that are equal to Manchester United here. So we'll say equals, but not just a single equal sign, because we're not doing something like defining a variable here. We're saying this is conditionally equal to, so only return true if this is the case. So we want a double equal sign. So df winning team, double equal sign, and then our team. And the value in that data frame is called Manchester United with that abbreviation here. And you will only return values that meet this exact string here. So we can't, have any typos or anything inexact. So if we run this, now we have this series. So the series is the same length as our data frame here, and any false value is a row that does not meet this criteria. And if we scroll down here, we can see a true value. So we know that Manchester United won this game in index 33. So now let's go ahead and use this to filter our data frame. And we can copy that. And just a reminder of the syntax here. And let's scroll down to this cell. So df, open brackets, and we can paste in that series. Hit enter. And now we have all of our data. And we can confirm that the winning team here in each case is Manchester United. So let's take a look at some more examples. So now let's show all losses by Manchester United. So df, open brackets, specify a column. So df losing team, again, conditionally equal to, so we want a double equal sign, Manchester United. And this is a good example, actually, with my typo here, of if we don't get this string exactly right, we're not going to get an error. There's nothing wrong with our syntax, but there are no values in the losing team column that meet this string because we're missing like an N right there. And now we get our output. So the losing team in each case is Manchester United. All right, so let's show all games now played in the first 5 weeks of any given season. So df will use the week column, and we need a different operator this time. So rather than an equal sign, we want the first 5 weeks. So we'll say less than or equal to 5. We can run that cell, and we get our output. See this week column here, and we'll scroll all the way down to make sure we only go to 5. Next example, show all games where the away team won. So we have a couple columns here for the home goals and away goals. So let's compare those two with a greater than operator. So df, open brackets. Now our columns here are going to be df away goals, and they have to be greater than df home goals. So you can use multiple columns here in your filter. Run that line of code, and we can check to make sure that all of these rows fit the criteria. So we want to make sure this column is greater than this column. This all looks good, so we can move on. Show all games that end in draws. So this will now be the exact same line of code. We're just going to change up our operators. Now we want these two values to be equal to each other. Again, in any filtering with equals, you want the double equal sign. Run that line of code. And as always, make sure that our output matches what we want here, which it looks like it does. All right, last example here is going to be show all games played since the start of the 2020 end year season. So should be simple. So df, open brackets, df column is going to be season end year, and we want that to be greater than or equal to 2020. And there's our output. Okay, so up to this point, we have only filtered on the indices. So meaning that we are taking slices of rows, but we're returning all of the columns. So now we want to be able to filter on both the rows or indices and the columns. And there are two ways to do that. One is with df.iloc here, and the other is with df.loc. So starting with df.iloc, here is our syntax. So we have the row filter, then comma, followed by the column filter. And the column filter is an optional argument. So if you don't specify a column filter, it's just going to return all columns. And we can input here any integers, single integers, slices, or a list of integers if you want to pass through multiple options. And you cannot input any Boolean series. So to understand kind of where this name comes from, loc refers to the location or locating data within your data frame. And the I in front of it means integer. So integer locating. And I'm just going to run this dictionary here. So this will help us out for the column indices. So this will just show the column name followed by the index of the column. So season end year is in index 0, or the first column in the data frame. So let's take a look at some examples. So let's show all data for the first and last games in the data frame. So df.iloc, the syntax is very simple to that, just simple filter, or very similar, I should say. Open brackets, and the first game is going to be a row here of index 0. So we can run that, and here's our data for that row. And this is the exact same thing as saying 0, comma, and then the way to return all possibilities is with the colon. Remember that the default, if you don't specify a comma and a column filter, the default is to return all columns. And using this colon here is the same exact thing. So we can do either. And the data for the last game is simply going to be index -1. Okay, so now let's show the winner of the first and last games. So this was simply a filter on the rows. Now we want to filter on the row as well as returning a single column. So this will be df.iloc, index 0 on the rows, and then comma. We need to find the index of the winning team column. Let's go to our dictionary here. Winning team is index 8. So df.iloc 0, 8, and this should give us a single value. So the winner of that game was Coventry City. And now for the last game of the data set, let's just change that row index to -1, Arsenal. And I think we can actually check this up here with our cell above. The winning team is, in fact, Arsenal. All right, so now let's show all data for the week number. So we're not actually doing any filtering on the rows. And just to demonstrate how this works, we'll say df.iloc. And we can't just input a filter on the columns because that is going to assume you're filtering on the rows. So the row input is mandatory. The column is optional. So to return all rows, we need to use that colon again, which means all, and then comma. Now let's specify the index for our week column. And in our dictionary, that is index 1. So colon, comma, 1. And this will return all data for the week. And this is pretty much, or exactly, I should say, the same as saying df week. Just another way of writing it. All right, so let's show all data for the week number, home team, and away team. So remember, you can pass through lists if you want to specify multiple values in your filter. So df.iloc, and we want all data in the rows, so colon and comma. Let's pass through a list, and we need these 3 indices. So week number was 1. Now we need the home and away teams. So that's index 3 and index 6. So within this list here, 1, 3, 6. And there is our data. And very important here, if you're specifying multiple values in the filter and you don't use a list, so if we delete this, you're going to get an error. So you have to make sure you have that as a list or it's not going to run. So let's move on to our next example here. Show the first 5 rows. Oops, let's make sure we find our data. Yeah. So show the first 5 rows of data for the week number, home team, and away team. So here we're going to be able to use a slicer. So df.iloc, and the first 5 is going to be 0, 5. So, or you could just say :5 if you're familiar with slices at all. And now comma, we want those same columns, so we can come up here and pull that information. We'll copy that, paste it into our filter, and there's our output. So we have the first 5 rows, and we could do this for any slice of indices here. So if you want maybe from index 1 to 4, there's your output. You could do from 100 to, this would be to 199. So any possible values there. All right, and our last example for iloc, let's show the date and the total number of goals scored for every other game in the data frame. So we'll use another slicer here, but now we want to set the step equal to 2. So df.iloc, we'll start with the first row equal to true, and we want to run through the entire data frame, so we're not going to specify anything here for the end. So double colon, and then a step of 2 to show every other. So this is going to show all even number indices. Then comma, let's filter on the columns as well. So we want the total number of goals scored. Let's go up to our dictionary and find the index number of that column. Total goals is index 7. So put a 7 in there, run this line of code, and there is our output. Actually, I think we want the date as well. Let's add that back in. Date is index 2, so we need to pass in a list. So a list 2, 7. And notice how when we pass through multiple columns, our output is always going to be a data frame. If we have only one column in the filter, the output will be a series. All right, so let's move on to df.loc. This is a lot more practical of a function, but it's important to study iloc as well because I think it gives a good representation of how Pandas is actually doing these filters. So with .loc, the syntax is exactly the same here. And again, the column filter is optional, so not specifying anything will return all columns. But this time we can use those Boolean series to filter again. So it's, again, almost identical to those simple direct filters on the rows that we did in part 1. And you can actually input integers, slices, and integer lists to filter on the indices like we did with iloc, but that will not work for any column filters. But in general, you're not going to be really using any of this for .loc. You're going to be creating Boolean series like we're about to do. So let's take a look at this exact same example which we did above. So show all wins by Manchester United, and the syntax is going to be very similar. And currently in this example, we're not filtering any columns. So, but we can again do the exact same thing with .loc. So df.loc, open brackets, and then df winning team, double equal sign, set that equal to our value, and this will return the same exact thing. So the .loc is actually an optional argument in this case because we're not filtering on the columns at all. And this is the exact same thing as saying comma, colon to return all rows. Okay, so now let's show the losing teams in all games Manchester United won. So let's copy this line of code here. And instead of specifying all columns, we want to show the team that they beat. So the losing team column. And now, previously, if we got rid of this .loc, this filter is going to work just fine. Actually, we have to delete that as well. But this is going to run just fine. But now that we're also filtering on the column here, if we delete .loc, we're going to get an error because the simple filter can only filter on the rows here. So this is not what we want. So instead, to return that filter, we'll put in .loc, and this will give us all of our teams that Manchester United has beaten. So here's our row filter, comma, and then the name of the column that we want to return. So we're returning exact column names and lists that match the column names in our data frame. So now let's show the season end year winning team and losing teams for games with at least 8 total goals scored. So if you kind of get familiar with the syntax of these questions, these are the columns we want to return, and then the filter on the rows is going to be 8+ total goals. So df.loc, rows filter comes first, so df total goals greater than or equal to 8, then comma, let's return these columns. And just like for iloc, if you want multiple columns here, we need to pass through a list. But with loc, you can give the exact column names. You don't have to look up the indices. So we want the season end year, winning team, and losing team in that list. Run that line of code, and here's our output. And just to confirm our data is also correct, we could pass through total goals as well. But it's important to notice, I think, that you can filter on this column here without actually including it in your output. But it's good to just confirm that our data is correct. And you can see that the total goals in all these games were 8 or greater. Last two examples here. Let's show all data, or show data for all columns except for the season end year. And our condition on the rows here is going to be where the home teams did not score. So df.loc, let's do our row filter first. So we have df home goals, and then they didn't score, so that is equal to 0, comma. Now we want all columns except for season end year. So if we just print out up here df.columns, season end year is the first column, or column index 0. So if we take a slice of this columns list here, so open brackets, and then from index 1 on, then we filter out that season end year. And so we can actually just copy this and put it right into our columns filter. Run that line of code. And when this runs, we should have our output. So the home team here scored 0 goals in all of these games. And notice how we have all columns except for the season end year. All right. And last question here. Now let's show the average number of total goals scored in games won by Liverpool. So our column that we want to output is total goals, and our row condition is going to be the winning team equal to Liverpool. I'll go ahead and copy that. So df.loc, df winning team equals Liverpool, comma, name of the column, which is total goals. And we can run this for now. And this is just going to give us a series of total goals that meet that condition. And we also want to show the average. And this is already a series, which is very convenient. So we can just add on a dot mean at the end. And there's our output. So just about 3.2 average total goals in Liverpool wins. And that is the end of our introduction to data frame filtering tutorial here. I also have an advanced version of data frame filtering for you to watch next. So go ahead and click on that video. It should be up in the corner as well as down in the description so that you can further your skills in data frame filtering, as this is a very practical skill. And please like this video if you enjoyed, and subscribe to the channel for more of this content in the future. And as always, thanks for watching.